Hello everyone and welcome to these sessions on quantitative methods for CFA Level 1. Now, when we talk about quantitative methods, it is basically mathematics of finance, and at your CFA program, the application of quantitative methods is extensive, not just for that subject alone. The connection of what you will learn in this whole subject is having implications ahead with many other areas of your curriculum. And in this journey, we are going to begin with one of the most fundamental requirement of mathematics of finance, that is time value of money. Now, this is very important for you to understand that money has value, and the value of that money changes over the period of time. For example, say you have $10,000 with you today, and you have decided not to keep that money idle. Of course, keeping money idle is never a right decision. So you have decided to invest that money, and say the applicable interest rate or the rate of return which you are going to get on that investment is say 12% per annum. So what is going to happen? Your $10,000 today, after 1 year time, won't just remain $10,000, that money will grow. So we have two different points, that is now and after 1 year. When I say now, I am talking about the present value of money, and when I say after 1 year, I am talking about the future value. So present value and future value of that same amount, the amounts are not going to be same. The base amount at present value is different, and the amount that you will get after 1 year maturity is something different. And that is where we can say that the value of money changes with the passage of time or over a period of time, and that is where we bring this title, time value of money. So let us do one thing. Let us write down some important aspect towards this. So first of all, write this heading, time value of money, and under this heading you please write concept of present value, and write this example carefully. If $10,000 is invested today at 12% per annum, after 1 year it will become $11,200. So no rocket science applied over here. Simply if you compute 12% of $10,000, 12% of $10,000, the interest or the return that you will earn in 1 year time, because the investment time horizon is 1 year over here, that interest amount what you earn will be 12% of 10,000, that will be 1,200, and $1,200 added to the principal amount invested will make it 11,200. So what is that 11,200? We can say, therefore, $11,200 can be considered as future value of today's 10,000. So keep this thing in your mind very clear. Today's $10,000 is becoming $11,200 after 1 year. So $10,000 is the present value, and $11,200 is the future value at 1 year time. So that $11,200 that you are going to receive after 1 year, obviously you are going to receive because you have invested some money today. You are going to get back your principal plus interest thereon. So the total maturity value of your investment is going to be 11,200, which we are calling as future value after 1 year, and the money that you have invested today is the present value. So now you can say that 11,200 is the future value of today's 10,000, and in other way you can say that $10,000 is the present value of that amount which you are going to receive after 1 year, that will be $11,200. So keep paying attention over here. We can say, in other words, $10,000 is the present value of an amount of $11,200 which is receivable after 1 year at interest of 12% per annum. So please carefully take note of this example, and then I take you ahead. Alright friends, I'm sure you have completed writing this example. Now in this particular example, the investment time horizon that we have considered was just 1 year. What if the investment period is longer and the interest rate is quoted on a per annum basis? Now there is something called compounding of interest. When I specify the rate of return or the interest rate as per annum, then annual compounding is implied. So first of all, if you can recall what you would have learnt in your earlier school days, you would have learnt computation of simple interest and compound interest. Just try to recall what is compound interest. So for understanding what is compound interest, let us first of all expand the time horizon of investment to a period longer than 1 year, say 3 years, and let me bring forward a new example for you. So just hold on, let me first explain this example and then I'll give you time to note it down. So in this example, what is mentioned, $10,000 invested today for 3 years at interest rate of 10% per annum will have maturity value of $13,310 after 3 years as explained below. How this will work? So simply you can take your calculator and check the calculations. Your present value of money that you have invested is $10,000, correct? And on that you will first add the interest for the first year at 10%. So you add interest for the first year at 10%. What it will be? It will be 10% of 10,000, that is $1,000. When $1,000 added to the principal amount of $10,000, the value after 1 year will be obviously 11,000 in terms of dollar. So your total value of investment by end of first year has already become $11,000. Now in the second year you will again earn interest, and that too at 10% only, but now it will be 10% of $11,000, correct? So adding interest for the second year at 10%, but 10% of 11,000 would become $1,100 as interest for the second year. The cumulative value by end of second year comes to $12,100. And now once you get $12,100, in the third year you will again earn interest at what rate? 10%, but on what amount? 10% of $12,100, and that would be $1,210. When you add up all these values, it will be $13,310 as the maturity value at the end of third year. So you know what is happening? Compounding of interest is happening. And what is the meaning of compounding of interest? Your interest earned in one period is getting accumulated to the value of investment, and then you are again earning interest on that cumulative value. So you are basically earning interest not only on the principal amount invested, but you are earning interest on the interest that you have previously earned, and that is why your money keeps on growing at a compounding rate, and that rate of interest still remaining 10%. Effectively you are earning a little more because of the effect of compounding. So we are going to literally deal with the effect of compounding in a more extensive manner as and when I take you ahead with the discussion. But before I move any further, I would want you to note down this entire example, and then we shall definitely move ahead. Alright friends, once you have taken note of this example, let me take you ahead and show you some important calculation. Alternatively, the future value can be determined as below. Now I am bringing forward a simple formula which you would have learned as the formula for computing the compound interest. So F stands for future value, P stands for present value, and to this you are multiplying a factor which is 1 plus I raised to n. What is this I? I resembles the rate of interest. Sometimes you may call it as I, you may even call it as small r. Both the variables can be used, both will convey the same meaning. 1 plus I raised to n. N stands for the number of years. Likewise, you may put T as the variable for number of years as well. So it's okay to use any of these variables, and let me now show you the impact of this calculation through this formula. In this formula, f equals to p into 1 plus I raised to n. So you know p stands for that present value, and 1 plus I raised to n becomes the future value factor. Now what is this future value factor? Future value factor is such a factor when gets multiplied to the present value, it will convert the present value into the future value. So we are going to learn two types of factors in this chapter. One is the present value factor, another is the future value factor. Right now what I have shown to you over here as 1 plus I raised to n is the future value factor, which when multiplied to the present value, it will convert the present value into the future value. Now how are we going to do this? 1 plus I. So first of all you have to add interest rate to 1. Interest rate is 10%. 10%, actually 10% means 10 by 100. 10 out of 100. 10%. Cent represents 100. So when I say 10%, it is 10 on a percentage basis. But when you make the absolute calculation, it is 10 by 100, that will give you 0.1. So 0.1 added to 1. So every $1 of today is going to become $1.1 after 1 year. That means if 1 is becoming 1.1 in 1 year time, 1 will become how much after 3 years? 1 will become 1.1 raised to 3. That means 1.1 into 1.1 into 1.1. When you do that, 1.1 raised to 3, it is giving the compounding effect, and that is how we compute the compound interest. So what we are going to do is we are going to compute the value of 1.1 raised to 3, that is 1.1 into 1.1 into 1.1. That will make it as 1.1 raised to 3. When you apply your financial calculators and you take 1.1 raised to 3, what you will get is 1.331 as your answer. That 1.331 becomes the future value factor, which when multiplied to $10,000 at present will make it the total value as $13,310. Let me show it to you over here. $10,000 multiplied by 1 plus 0.1 raised to 3. So 0.1 is mentioned as the substituted value of the variable I, and 3 years is the substituted value of the variable n. And now what we do is we find that value 1.1 raised to 3, which will be 1.331. That when multiplied to $10,000, the future value becomes $13,310. So we can arrive at this simple formula for computing the future value, that is f equals to p into 1 plus I raised to n. Now from this equation of future value, if I ask you to compute the present value, what you would do? You would say obviously p equals to f divided by 1 plus I raised to n. And guys, at your school stage in mathematics, what you would have learned under exponential rules, if it is x raised to minus n, that is x to the power minus n, it becomes reciprocal of x raised to n. I repeat again, it is x raised to minus n that becomes reciprocal of x raised to n, that is 1 divided by x raised to n. As a result, if it is f divided by 1 plus I raised to n, you can rewrite that as f into 1 divided by 1 plus I raised to n, that is reciprocal of 1 plus I raised to n, which can also be written as 1 plus I raised to minus n. So the present value calculation, if you want to make through the future value, it will be future value multiplied by the present value factor. So 1 plus I raised to minus n becomes the present value factor. And I would want you to carefully take note of both of these formulas of computing the present value and the future value. The first one over here is the future value, and then the next one over there is the present value computation. So you can define the variables. F stands for future value, P stands for present value, and I is the interest rate, and N is the number of years. These two variables you can change. Sometimes you may mention R instead of I, or you may mention T instead of N. It will not make any difference to your calculation and your approach. So I want you to carefully take note of this whole thing, and then I take you ahead. Alright friends, once you have completed writing this whole thing, carefully look into one point now, that is this part of the calculation we have observed, right? And we have seen the details of the calculation even year on year basis, but in reality we are never going to make calculations that way. Calculations will always be made directly like this. How about using this particular formula, that is P equals to F into 1 plus I raised to minus N. Now if I ask you to find the future value of today's $10,000 with 10% per annum interest and the time horizon of investment being 3 years, today's $10,000 is becoming $13,310, because what you did, you found the future value factor and then you multiplied the future value factor to $10,000. So $10,000 multiplied by the future value factor, that is 1.331, becomes the future value of today's 10,000, that is $13,310. Now inversely, if I want to compute the present value, suppose I tell you that after 3 years from now the maturity value of your investment is going to be $13,310, and I want you to determine the present value of the same. You know what you will do? Which was the factor that has helped you to land up at the future value from that present value of $10,000? It was that factor which we call as the future value factor, that was 1.331. So now what you do is, if you take an inverse calculation, you take the future value, that is $13,310, and you divide it by the future value factor. You know what you will get? You will get back to the present value. And that is why we are taking the reciprocal of the future value factor to arrive at the present value factor. So what is the reciprocal of 1.331? The reciprocal of 1.331 will be obviously 1 divided by 1.331, and if you want to find that directly, let us go to that extended example. I would say over here, determine the present value of $13,310 receivable after 3 years, where interest rate based on annual compounding is 10% per annum. So the present value factor is always denoted by 1 plus I raised to minus N, which in this example will be 1 plus 0.1 raised to minus 3. And if I take it on the reciprocal of that future value factor, I can rewrite the same thing as 1 divided by 1 plus I raised to N. That is the reciprocal of 1 plus I raised to N, which in our example will be the reciprocal of 1 plus 0.1 raised to 3. So 1 plus 0.1 raised to 3 had a value of how much? 1.331. So just take the reciprocal of 1.331. What you will get is something as a fractional value. Over here I have restricted the calculation to 6 places after decimal. Now how many places after decimal you need to consider and for which all calculations, we are going to learn that in detail ahead. As of now, just try understanding that yes, we have restricted the present value factor calculation to 6 places after decimal. Now what? When we multiply this factor, that is 0.751315. First of all, what is this? This is called the present value factor, because we originated this calculation from this formula, that is 1 plus I raised to minus N. This is the present value factor, which is reciprocal of the future value factor. So fundamentally, let's understand one thing very clearly. Any interest rate, any time horizon, if there is a future value factor, reciprocal of that or inverse of that will become the present value factor. If there is a present value factor, the reciprocal or the inverse of that will become the future value factor. Now what? We will be just multiplying this factor, that is the present value factor, on the amount that we are expecting to receive after 3 years, that is $13,310, and what we will get actually is the present value of that amount receivable, and which is exactly $10,000. So please write up this entire example as well, and then I take you ahead. Alright friends, once you have completed writing this whole thing, let me explain one very important aspect over here. We have now observed through this example that there are two values, one which we are identifying as present value and one which we are identifying as future value. Present value in this example is $10,000 and future value in this example is $13,310. You will always find that on the present value interest is getting added, and then you get to arrive at the future value. So future value will always be a greater value and present value will always be a smaller value, because I would say, as per this example, today's $10,000 is equivalent to $13,310 which you would receive after 3 years. So if someone is giving you a choice that either you pick $10,000 today or you pick $13,310 after 3 years, if interest rate is 10% per annum on annual compounding basis, you would not make any difference you pick any of these choices. You pick $10,000 now or you pick $13,310 3 years later, it will not make any difference at all. So we would say the present value is always going to be smaller than the future value. That is why the present value of a cash flow, because I am identifying that future value as a cash flow, because after 3 years I am going to receive that amount. That is a future cash flow for me. That future cash flow, when you compute its present value, the present value is always going to be smaller than the future value. If the present value is always going to be smaller than the future value, we can call present value of a cash flow as discounted cash flow. And that is why the rate of interest or the rate of return that was considered for this purpose is called discounting rate. So when you are converting a future value to its present value, you are converting a future cash flow into a discounted value of cash flow, and whichever rate of interest is the applicable interest rate over there is therefore also called as a discounting rate. Now from the perspective of an investor, what exactly is the discounting rate? We are going to have extensive discussion about discounting rate in the classes ahead, but as of now you should understand this discounting rate is a kind of expected rate of return for the investor, because investor is expecting that rate of return, and that also considered as cutoff rate. A cutoff rate indicates that investor is not going to accept any investment proposition, any investment proposal which is offering a rate of return lower than the discounting rate or that cutoff rate. In our example, if that cutoff rate is 10%, the investor will not be willing to make any investment if the rate of return goes anything below 10%. So that is also considered as a minimum expected rate of return or the cutoff rate. So we are going to understand a little detailed discussion on discounting rate, required rate of return, expected rate of return, cutoff rate. What exactly is the connecting point in these terms? They are all pinpointing to the same rate of return, but why we are using which term in a specific situation, we'll talk about that. And that time we will bring the angle of what we call as opportunity cost of capital. So those discussions are yet to come, but what I have just explained to you as an initial understanding, I want you to note it down. So in your notebooks, you first write this point: the present value of any cash flow will be obviously less than the cash flow itself. Such present value is therefore also known as discounted cash flow. The rate of interest which is used for determining the present value of the cash flow or the discounted cash flow is therefore known as a discounting rate. And the discounting rate indicates the expected rate of return for the investor. It is also known as a cutoff rate because it indicates a minimum rate of return that the investor will be expecting from the investment. So I want you to note down these important points and then I take you ahead. So quickly take note of this whole thing.